This video is the first in my series about the observer design pattern. I am planning on doing 5 or 6, hopefully short ones. The first video covers the problem, then the pattern itself, the old version. Then I apply the pattern to the problem, and Java has some built-in tooling in the form of the property change subject, so we will see that. And then I show another approach using lambda expressions. It's still the overall same idea. The last one is sort of the same as the lambda, just with method references instead. Also the same idea. Yes, there are plenty of videos out there on how to implement the pattern in Java. I do this because I enjoy the video making, but also because I wanted to make a more complete video or series of videos about the pattern. The pattern was first documented over 20 years ago in this book, which means it must have existed before that. So 20 plus years old, and things obviously change. The pattern has evolved, and I plan on covering different variations of the same idea. First, let's start with the problem we're trying to solve. I will illustrate with a little diagram here and later show a very simple implementation of it. Let's assume we have some kind of sensor which reads measurements. It could be outside temperature, a weather sensor perhaps. Whenever the sensor makes a new measurement, we want a few things to happen. Some monitors should be updated with the current temperature. We record the temperature in some kind of log, maybe a file. And we have this alert which shows a warning if the temperature is too low. This is the setup, for now at least. Maybe I want other entities reacting to the sensor in the future, and that is what causes the problem. I have a simple code sample illustrating this, so let's just have a look at where we start and then implement the basic idea. First, the class representing the sensor here. There is just this method, which when called will generate a random number and then print it out. Then we have the sensor log class, which writes out data to a file. Here is the UI showing the current temperature. Don't worry about the platform run later here. The point is that I have a label which is updated with some text. Then the sensor alert class. It checks if the temperature is too low, in which case an alert is shown. The alert part is just in this other method here. And finally, the start method to run everything. I create the sensor class, then start another thread, which keeps requesting the sensor to update its temperature. There is a sleep for 1 second, and then looping around to start over. A new UI class is created and shown. And if I run it, we see the UI and the sensor prints to the console. But the other classes are not connected yet. So let's try out the poor solution first, direct dependencies. For each peripheral I want to react to the sensor updates, I update the sensor class. Let's start by making the sensor update the UI. I need a field variable, a reference to that UI class. And I need to inject the current conditions UI through the constructor. And then in the update method, I just call the UI class's set method. So I have to convert the int measurement to a text because that's what the UI expects. To tie the UI to the sensor, I had to update the sensor class. Next, the sensor log class. Once again, I must update the sensor class. First the field, and the constructor parameter, and in the update method we call the log method on the sensor log object. And the last one, the alert class, again the sensor class must be updated, the field variable, and the constructor parameter, and calling the alert object down here. Now I just need to go back to the start method to update the sensor constructor call. There. And let's test it. So everything seems to work, that's nice. There, after a bit, I also got the alert for the temperature when it's too low. And here's the log file for the temperature history. So my solution works, but every time I need to add or remove these other interested objects, I have to update the sensor class. This is inconvenient, and the interface for each of the other classes that are interested in my sensor, they have different methods, so that becomes slightly confusing. For example, for the UI class, I had to convert the integer to a text. The fix to my issue here is, of course, the observer pattern, so I will introduce that in the next video. Thanks for watching.